there were different attempts to justify this kind of reasoning. Prior to the 20th century, for example, and draw the much simpler conclusion that he broke the vase. If you would do so, you would be acting in accordance with a philosophical rule of thumb called Occam's razor, named after the scholastic philosopher William of Occam. The rule can be summed up as following. Always pick simpler solutions, since they are more likely to be correct than complex ones. But why do we think that? Why would we think that simpler solutions are more likely to be correct? In the history of philosophy, there were different attempts to justify this kind of reasoning. Prior to the 20th century, for example, it was commonly believed that nature itself is simple. So, of course, simpler hypotheses about nature are more likely to be true. This view often drew from theology. Aquinas, for example, wrote that nature does not employ two instruments where one suffices. Perhaps the most well-known instance of such a justification. Can be found in Copernicus' rejection of the Ptolemy's geocentric model of the solar system, which was a quite complex model, in favor of a simpler model. Copernicus adopted Plato's conception of celestial bodies as being perfect, and
Occam's razor law was stated by philosopher William of Occam. It is also known as the law of economy or the law of parsimony. The law says that pluralitas non est ponenda sine necessitate, meaning that plurality should not be posited without necessity. The principle gives precedence to simplicity. If there are two competing theories, then the theory with the
if there are two competing theories, continuous
simpler explanation is to be preferred.
if there are two computing theories,
The principle is also expressed as entities are not to be multiplied beyond necessity.
are not to be multiplied based on the necessity.
The principle was in fact invoked before Occam by Durandus of Saint Pourçain, a French Dominican theologian and philosopher of dubious orthodoxy, who used it to explain that abstraction is the apprehension of some real entity, such as an Aristotelian cognitive species, an active intellect, or a disposition, all of which he spurned as unnecessary. Occam, however, mentioned the principle so frequently and employed it so sharply that it was called Occam's razor. He used it, for instance, to dispense with relations, which he held to be nothing distinct from their foundation in things, with efficient causality, which he tended to view merely as regular succession, with motion, which is merely the reappearance of a thing in a different place, with psychological powers distinct for each mode of sense, and with the presence of ideas in the mind of the creator which are merely the creatures themselves. This explanation by Occam is indeed simple yet fascinating. It's interesting to note how this philosophical law has been used by various scientists over the ages. Let's understand Occam's relationship with science. Many scientists have adopted or reinvented Occam's razor, as in Leibniz's identity of observables and Isaac Newton stated the rule, we are to admit no more causes of natural things than such as are both true and sufficient to explain their appearances. The most useful statement of the principle for scientists is, when you have two competing theories that make exactly the same predictions, the simpler one is the better. In physics, razor law is used to shave away metaphysical concepts. The canonical example is Einstein's theory of special relativity compared with Lorentz theory that rulers contract and clocks slow down when in motion through the ether. Einstein's equations for transforming space-time are the same as Lorentz equations for transforming rulers and clocks. But Einstein and Poincare recognized that the ether could not be detected according to the equations of Lorentz and Maxwell. By Occam's razor, it had to be eliminated. The principle had also been used to justify uncertainty in quantum mechanics. Heisenberg
to present evidence contradicting the notion of geocentric zeros. What follows was a profound change in the approach. What follows was a profound change. What is Occam's razor is when there is conflicting theories, the simpler explanation will be preferred. Shuffle all the unnecessary assumptions of constructing or assessing the validities of arguments. Polarity should be opposed composite. Okay, with geocentrics. What followed was a profound change in the approach to inquiry in the actual world. Conventional wisdoms, including the dogmas of Catholic Church, was no longer blindness. Okay, conventional. This one is who? The scientific revolutions with the publications of Nicholas. How to pronounce her names? Nicholas Copernicus.
Before Nicolaus Copernicus.
Copernicus is the forefront of this scientific revolution. Systematically gathered the evidence of observation from which the laws of the nature could be inferred. There's also a class of the thinkers, scientists, Nicholas Copernicus.
Virtually everyone believes. Before Nicolaus Copernicus.
Copernicus. Galileo Galilei was a mystery scientist. Laid the foundation for the works of Isaac Newton. Okay. Describes scientific inquiry is a process inferring a general rules from a particular instance. Sunspot, study of gravity. They dropped 2 balls at different weight from the tower shows that they fell at the same speed. This refutes Aristotle's assertions that heavy objects fall faster than the lighter ones. Because orbits Earth orbits the Sun, the orbits of the planets could be explained. Doubting the words. Okay, this one is scientific. Relations. Is it that relations?
This is a roughly 300-year period in Europe is one of the standard stops on any tour through the history of the phenomenon known as the Renaissance.
Scientific relations. And things in their quarters. Francis Bacon's advocate on the methods of observation. That's correct.